Tree diagrams are just an organised way of showing the probabilities of certain events happening. In this case here, there's two events. We spin the spinner and then we throw a dice, depending on what the spinner shows us. Now it says that if the spinner shows an even number, the dice is thrown. That means that if it's odd, it doesn't get thrown. So we don't have to fill anything in down here because it kind of ends here. There's nothing further to happen here. But if it's an even number, the dice is thrown. And if we look at the possible events on the dice, it can either be red or green. So there's two possible outcomes for this. That means we're going to put two lines coming off. So we need to label these lines. The possible outcomes were red or green. We can label that red, and this one green. Now we need to think about the probabilities of each one. Now it's always best to think about probabilities, well, most of the time anyway, in terms of fractions. Here we have the numbers 1, 2, 3, 4, and 5. Now in total there's 5 different outcomes. Out of those 5, we think how many are even? So 2 and 4, those are both even. So there's 2 numbers out of those 5 which are even. And the odd numbers, there is 1, 3, and 5. So there's 3 out of 5 odd numbers. And this is great because if we add 2/5 and 3/5, then we get 1. And 1 is a certain probability that's going to happen. And there isn't any other possibilities apart from getting even or odd. So that has to be the case, but that's certain. And then we look at red and green. This time it's out of 6 because there's 6 sides on the dice. So out of those 6 sides, 5 of them are red. That gives us 5/6. And 1/6 is green. And again, this works nicely because both of these add together and give us 1. And it's certain that we're going to get red or green. Now we've done the tree diagram, we can move on to part B. And part B, we're probably going to use this tree diagram, and it's probably best to work out the probability of getting an even number and the colour green. Now, and in statistics, this kind of signifies to us that we're going to be timesing together two probabilities. Generally, we're timesing if the word is and we're adding if the word is or. So it's one event or another, we're adding and timesing if it's and. But this depends on the type of event. They have to be somehow related. So if we look up here, we're going to be taking the route along the tree diagram, but we have to get an even number. And then once we've got an even number, we have to get the colour green. So you can see that we need the probability of 2/5 and 1/6, which is going to be 2/5 times by 1/6. When we're timesing fractions, you times the numerators and the denominators, so 2 times 1 gives you 2, 5 times 6 gives you 30. Now we can leave this as 2 over 30. There's no need to simplify this down any further, it doesn't ask us to do that, but we could if we wanted to. We could go down to 1 over 15. But it'd be silly if you were to try and simplify this and you made a mistake. That could lose you the answer mark if you didn't get that correct. So it's probably on the safe side just to leave it as that. Especially providing we're not going to be using this any further. There's no further parts to this question. Now just to check that seems reasonable. 2 out of 30 or 1/15, that's quite unlikely. And we can already see that getting green is going to be unlikely. And also getting even is unlikely because you've got more chance of getting an odd. So we probably are going to be looking for quite a low chance of getting both of these.